I'm going to just quickly start with a show of hands. How many people love what they do? Love, look at all those hands. Embedded devices bringing about the Internet of super awesome things, IOSAT, trademarked, is an incredible calling in the world. And I've been doing it, as Tim mentioned, for quite a while in a number of different roles. Actually ran some mining operations in a previous job, did biomedical devices. And for M2MI, I spend a lot of time with our customers, which is awesome because I get to learn what goes into making a fish finder. Or how do you keep the chocolate really cool in those Belgian stores when you walk in, you just get that waft of smell. I get to learn about oil refineries and metal cutting tools and, let's see, how people are figuring out how to siphon off oil and gas throughout countries as their subsidies go away. How do you find black rhinos and poaching? I mean, the use cases are incredible. And one of the things that, other direction, there we go. One of the things that has become absolutely clear with the Internet of Things is that we all, as developers and engineers, are taking the world and putting it into the hands of the ordinary person. We're giving them the opportunity to control their home, to control devices that are sitting out in fields that no man has ever been before, possibly a drone. And we're giving a lot of opportunity to people to learn new ways to play using devices. But that opens up some challenges because we as developers tend to be fairly technically savvy. That's not true of all of our users. Some of them are. We're all experts in our own lives. We're all experts in our own requirements. But there's some surprising information out there. For instance, 50% of US households, the 50% of US households who know what Wi-Fi router they have, what generation, are running old technology, and 57% of households have no idea. So maybe they're running, protocols that were ratified 12 years ago. Maybe it's held together by duct tape. Only 64% of US adults actually have a smartphone. Now, I don't remember seeing a bunch of flip phones out there with, OMG 665, but clearly that's because I live in Silicon Valley. So everyone I see, even from kids to grandparents, have smartphones and know how to download an app. Now, one of the maybe the most disturbing for the Internet of Things information up here is not the privacy one, we'll get to that, but it's actually the fact that only about 59% of adults in developing countries, so not even just in the US, in developing countries, are interested in having a technical job, having something that would fall into STEM. Now, part of what we're doing with all of our wonderful devices is we're turning every job into a technical job. If you want to work at a restaurant, you've got to figure out how to use point of sale systems. You've got to figure out how to do that wine menu on the tablet when somebody asks for a glass of Cabernet or a glass of red if you're from the States. And figuring out exactly how we're going to be able to take these devices and make sure that we really are wrapping them around the user instead of the alternative becomes a pretty high technical burden when folks really aren't interested in changing that. Now on to privacy. This is one of my favorite topics because we actually talk a lot with customers about privacy. Everybody, first question out of their hands. Who owns the data? Do I own it? If I own the data, who can I share it with? And who do I have to notify that I'm sharing it? Well, it doesn't really matter, opt-in. 66% of people, or US adults, actually US internet users, let's be very clear, think that a privacy policy means that they're going to keep your data private. That's more than 50% think that privacy policy means private data. I've read a few of them because I'm a lawyer's daughter. It does not mean that. It means I can sell your data. If you are not paying for a service on a connected device, if you're not paying a subscription, chances are your data is the product. So this is a great misnomer. But we're going to be having to learn more and more as we add more security issues into devices, which is just going to happen because that's the trajectory we're on. Folks are going to start paying attention to those. They're going to start asking, wait a minute, how did this hacker get access to my bathroom camera? And did I really own that data to begin with, or did the camera company? Because that's, I guess, valuable information. So we see a lot of actually we see a lot of devices that have been designed for the elderly with TV remotes. I don't tend to watch too much TV, so I still have trouble getting a remote to work. This down here is a combine, a harvester for a farmer. So our farmers are becoming data scientists. That's 3 different screens. You only have 2 eyes. You can't stare at 3 different screens at any given time. But that's what it takes to harvest a field today. We also ask people to do things like, hey, can you restart the VNC? This is to a groundskeeper on a golf course trying to remote into his $1 million water pump. Why? Because somebody did a VNC to the HMI. Wait till you see the cell phone bills when they try to ship those water pumps to Guam. Regardless, we're also asking, folks who are, again, experts in their areas, line workers. They know what a transformer does. They know how to install very technical equipment. They do not know how to do a VPN connection. Not really something that they should have to learn how to do. We need to figure out how to incorporate all of that information to be able to do these things automatically. And frankly, it starts with us in this room. Because it's not just about, hey, there's got to be some middleware software somewhere that does that. The middleware software, and I run one of those companies, so the middleware software that's got to do that actually needs information from the devices. It needs contextual information. It needs ecosystem information. We're going to talk a little bit about what some of those steps are and how, as a community that's helping to define the frameworks around IoT, how we can help sort of propagate that so that people like me have easier jobs. It wasn't all really just about the open source community. I need my job to be easier. So how do we remove friction from some of these systems? I love this statistic up here that 60% of wearable owners love their devices. First of all, it's too bad it's not higher. Second of all, only 20% of them are delighted by the apps. So consumers, workers love the devices, not so happy with the apps. Why? Because they have really high expectations of what those devices can deliver, and their experience of what's being delivered is usually the app, because we take a device and we add a screen. And when you add a screen, people expect really big things. They want to know, how many calories did I burn, and can I fit into that dress next weekend? That's not what the app tells me. The app just sort of tells me, how many steps I've taken 5,000 times each day, and they're not even giving me the averages to let me know if I'm taking more steps or not. Our CEO, hopefully he's not watching the streaming right now because I'm not sure he'd want me to tell you this, bought a lock for his garage. Now, he has a couple of motorcycles. So this lock was going to tell you whether anything was breaking in. It's going to send you an SMS. It's great. I know when somebody's breaking into my valuables in my garage. Well, motorcycles make a lot of vibration and a lot of noise. So as he drives in and out and not paying attention to his phone left inside the house, he managed to burn through almost all of his text messages in the month. Why? Because he got 10,000 alerts, basically, from this thing in the span of 30 minutes. Not good design. Clearly, somebody is not breaking in 10,000 times in less than 30 minutes. Where do we put that information? Is that something that goes in the middleware layer? Or is that something that goes at the device layer? Or is that something that goes in the conference between the two. This is something that our engineering teams talked a lot about, in fact, too much about. This is an ID for a bag. Now, the back end folks want to have it look something like this, A5682C43C. Why? Because that's a unique key identifier in our lockbox system. Great. That gives it a unique identifier on the system. Makes sense. Plus, it's kind of a pain to go and map it to something that's a little bit more readable, maybe some monogram plus the flight plus the seat plus the date it's leaving. Front-end guys are like, look, I can't even tell you what that is. So, that's not even the passenger experience level. That's just how do we, as operators, how does somebody standing out on the tarmac have an idea of what this is? Is this a person? Is this a bag? Where is it going? What do I need to do with it? But where do you put that information? Do you put it up at the front end in an app somewhere, or do you assign it to the device? Well, the device is always the single point of truth, right? So the more things we can put on a device, the better. Fabulous. Devices have limited resources. So we go back and forth, and figuring out exactly where we have space and how to optimize that, that's not something that, as a device developer, you can really portend. When you create a GPS tracker that's cheap, did you know I was going to put it in a bag? Probably not. In fact, for this particular company, definitely not, because he started out in containers. We never really know exactly where things are going. And when things start to get complex, who do you ask? Who do you call? You call Einstein. Why? Because he was brilliant at making complex things, I'm going to say simple, but I do have a PhD in physics. Everything should be made as simple as possible, but not simpler. Providing a measure of flexibility and exactly where we can go with devices from the device level up gives us systems people pure joy. It means that we can go through and we can add in just a few little dots that help us connect up to the rest of the piece of the pie. Einstein understood this very well. I think many of the people in the room understand this very well. But figuring out what is that level of simplicity beyond which we can't go, and what are we willing to pay for it, and exposing those costs, both in resources as well as in dollar signs. The customer with the baggage system turned around to his manufacturer and said, I can do 10 million of these if you can put them in a sticker, and I can pay 50 cents for them. That's a $25 bag tag in there. Turning that into a 50-cent sticker is not doable, and if anyone here can do it, talk to me afterwards. I know a lot of people who are working on it, and I can't wait until it's available, but those are the types of trade-offs and the types of communication that need to happen between the ecosystem. And every device is part of a process. So again, getting to the point of how do we help from a device standpoint, from building the device up, where what you know is the device that you're working on, the functionality that you're intending, how do we pull that together into the processes in which that device is going to live? It's hard to imagine these when you're working on just the device. And it's hard to imagine these when you're working on a device that can go into any number of situations. We use the same basic GPS trackers and temperature sensors across many different verticals, from agriculture to airports to, actually we had somebody requesting some of the same temperature sensors for a smart home ambient intelligence device. Didn't quite work for that scenario. But figuring out how to propagate contextual information about the device. So it may not be all that useful for the device itself. 5 degrees, that's temperature on a temperature sensor. But there's additional information that that device has about itself and potentially about its neighbors as we start working into interconnected devices and potentially about the network connection that it has. Providing that kind of information as part of a payload allows us as systems people to be able to start to fill out, again, that larger picture. Filling out that context around allows us to remove some of the requirements from the device side. Security is a great example. I'll talk about that a little bit more in a minute. But contextual information can let me know whether a light bulb has been spoofed. If I know that every other light bulb in the room is turned on, and I know that that light bulb is in good health, i.e. it just got changed, but all of a sudden it's sending me alerts that somebody should go down there, chances are something's wrong with that bulb, and it's not that it's broken, it's been spoofed. You can go, and then I can go and look and see, okay, so where is the location of that thing? How much, is this a regular behavior pattern, or is this something that's new? I.e., has somebody been poking that device for a while? And we see this a lot with cellular connected devices, being able to grab the ecosystem information and being able to cross-verify. If I had a smart water system, and one pump kept saying, hey, my downstream flow is 5x what my upstream flow is. That's not possible. You can't have more coming out than going in. Again, PhD in physics. You can't create matter in the middle of a water pump. So when we went and looked, we saw, wait a minute, that SIM's reporting the fact that it's in Romania. It's not so good, because the pump is sitting in Chicago. So clearly something was amiss, but we wouldn't have gone and asked that question of the system if we hadn't noticed that the behaviors didn't align. And the more information that we as systems people can get about devices and about the environment in which they are operating, the more we can place together these pictures. Mark actually just talked about this, devices being sort of a living object. A lot of us as developers and engineers think about installing, connecting, configuring. Great. Those are the first things we test. It's some of the first things we build. We do a lot of testing on those at M2MI. But these products are sitting out in the environment for 3, 5, 10, 15, potentially, years. And we're trying to figure out, how does the customer continue to interact with that device? What intuition do they naturally have about the device? And does that change? It's a hard thing to project forward. But thinking about your assumptions and what we're taking for granted, and not only does it change with an individual, but it changes within the ecosystems. All of our IoT devices sit in an ecosystem. The ecosystem might be your home. It might be, the airport. And all of these interactions are not just, device to device. Sometimes they're company to company. Airports are a wonderful microcosm of sometimes high school. But getting all of these supply and value chain members to come together in order to make sure that there's a service that can deliver your bags to your Uber, that takes about 5 different players, and they're different in each airport. And that's only for one airline carrier. So how do they share information and context and pull all of that together? Devices actually have an important place to play in that, particularly when you've got multiple owners of the data and stakeholders. I think there's some very interesting implications for some of the frameworks that we've talked about. In fact, Greg Burns was talking about it yesterday in IoTivity versus AllJoyn, about how do we provide some of this information as part of the frameworks. So before I run out of time, security. We are all IoT global security citizens. Security is hard for end users to manage. Why? It's not just because it's technical, it's not just because it's complex, but it's because it's another thing they have to think about. Devices that can help the user not have to actively think, this seems very logical, get adopted a lot faster. People will pay more for something where they can connect and just click a button. Or where you can go up on a lighting pole, you install a light, you come back down, and you click one button. And automatically something in the light goes off and figures out, here's my location, here's the street I'm addressed to, here's my Here's the configuration I need to download, and the installer gets to move on to the next thing. If he's got to sit there and, again, set up a VPN, it's probably not going to happen. It's certainly not going to happen right for the first couple of times. So my favorite piece, and I'm almost done here, my favorite thing is always code for a future that you can't imagine. Being able to put in little goodies into devices that maybe aren't fully used today, but which you can use later on in an update. That's how we end up in an Internet of Things that's living and vibrant and really interesting for the future. Thank you.